Hi everyone, this is supply chain management and logistics. In the last class, I explained about the difference between the continuous review system and period review system. Especially, I focus on how to decide when to order and how much to order under these two different the inventory control system. Today, I'm going to show you how to determine when to order and how much to order under the continuous and period review system by using the specific example. Let me get my note first. So this is the example. So let me handle that the continuous review system and the period review system, okay? So given information about this is, let's say you have average demand that is, let's say D is 18 units per week. So here's a weekly average demand is 18 units, okay? And standard, the deviation of demand is sigma t is 5, okay? So basically say I can weekly demand is an unknown variable, just a random variable. And the following the normal distribution with the mean is 18 and the variance is 5 square, 25, okay? And then lead time is L. Two weeks. That means once you place order, you can receive that ordered product 2 weeks later. And then unit inventory holding cost is $15 and ordering cost is $45. Okay. And then cycle service level here is 90%. That means this inventory control system is designed to have 90% of the cycle service level. Okay. So with this, let's have a continuous review system first. So under the continuous review system, that first of all, I have to calculate the sigma L. The standard deviation of demand in the due time, that is a sigma t, multiplied by square root of L, that is 5 multiplied by square root of 2, that is a 7.1. And then cycle service level is 90%. Then all I have to take a look at the table, standard normalization table, and find the corresponding G value to the 0.90. So take a look at that. From the table, inside of all this probability, I'm looking for close to the not 0.9. 0.9 minus 0.5 is 0.40. Okay, so which one is that? 0.40 is around here. Okay, between the 0.3997 and 0.4015. Okay, so I think it's a 0.3995 is closer. Okay, then the 0.4015. So the corresponding the G value is 1.28. Okay, so that is 1.28 from this standard normalization table. Okay, so in other words, I can get the G is less than 1.28 is 0.90. Okay. So now I'm ready to calculate the safety stock. Okay. Safety stock is just a G multiplied by sigma L. 1.28 multiplied by 7.1, that is a 9.1. Approximately is a 9 unit. Okay. And then I can calculate the real point. What's the real point? Just the average the demand during the daytime plus safety stock. Okay. That is just the D multiplied by L plus G multiplied by sigma L. Okay. So here, that is weekly average demand is 18 and the lead time is 2 weeks plus, so safety stock is 9, so the order point is 45. Okay, so this way I can determine then when to order the order point. That is next, how much to order, that is EOQ, just a classic EOQ formula. 2ds and divide by h and make a square root. So here's that annual demand is just the average demand, 18 weekly demand multiplied by how many weeks we have in a year? About 42 weeks. So there is a 936. So EOQ is 2 multiplied by 936 multiplied by 45 divided by 15 and make a square root. That is 74.9594. And that is about the 75 unit. Okay. So what's going to be total cost here? Here, if I do this, then again, there's a 3 portion of this cost, the inventory holding cost plus ordering cost plus safety stock holding cost. Okay. Excuse me. And inventory holding cost as usual, because EOQ is 75, divided by 2 give me a cycle inventory and multiply by 15 plus 936 annual demand divided by 75 EOQ give me an order frequency in a year and multiply by 45 plus safety stock is amount is a 9 and multiply by 15 unit inventory holding cost. So if I calculate, that is $1,259.10. Okay. So if I conclude that is the real point is 45 and EOQ is 75, that means under this continuous review system, again, this is a continuous review system. So that's why you keep watching your inventory. Okay. You just stand on the warehouse and keep watching your inventory over the time. And you find out inventory level exactly same with the 45 unit, then you have to order. How much? The 75 unit. So again, next time, you just continue to the watching over your inventory, and then you find out the inventory level is hit the 45 unit again, then you place order how much? The 75 unit. So in that way, in a year, you pay the $1,259.10. Okay. So that's about the continuous review system. The next one is periodic the review system. Okay. So let's in the periodic review system, let's take the easy one first. There is a review period, P. that is just EOQ divided by annual demand and multiplied by 52, okay? So I'm just try to change into the weekly basis from the yearly basis. So EOQ is the same. Nothing changes from the continuous review system, okay? Then 936 multiplied by 52, that is a 4.2. So about the 4 weeks, okay? And then calculate the target inventory level first. I need to get to know that is what is a sigma P plus L, the standard deviation of demand during the P plus L time. That is sigma T multiplied by P plus L and square root. That is 5 multiplied by 4 plus 2 and square root of them. Okay, that is 12. Okay, and then safety stock become 1.28 multiplied by 12, that is 15.36. It's about 15. And then now I'm ready to calculate the target inventory level. There's a T. That is just the average demand during the P plus L time plus the safety stock amount. Okay, so that is 18 multiplied by 4 plus 2 plus 1.28 multiplied by 12. So that is 123. Okay, and then finally, what is the total cost? That is, as usual, D multiplied by P divided by 2, and H, I just copied the formulas from the previous one. P multiplied by S plus H multiplied by sigma P plus L, the safety stock. That is, or I just plug the numbers here. 4 multiplied by 18 divided by 2, cycle inventory level multiplied by 15 plus 936 annual demand divided by 4 multiplied by 18 order frequency in a year, and then 45 plus 15 multiplied by 15. I already calculated the safety stock. So according to my calculation, that is 1,350. That's all. Okay. So what happened to this period review system? Again, in the period review system, unlike a continuous review system, you don't have to keep watching your inventory at all. Okay. It's time to time, you visit your warehouse, you check your inventory and place order. Okay. So when I have to visit my warehouse every 4 weeks, every time is 4 weeks, then I visit my warehouse and place order. But how much? No matter how much inventory I have, when I visit my warehouse, check out my inventory, I just order up to the inventory level increase up to 123 units. Okay. So that's the target inventory level. Okay. So whenever I place order, I'm going to order a certain amount to increase my inventory level from the current one to the 123 unit. For example, the 4 weeks later, when I visit my warehouse, I find out inventory level is the 30 units. Then how much I have to order? I have to order a certain amount to increase from the 30 unit to the 123. So total 93 units I have to order. So if I order that way, then what happened to my annual inventory, annual cost, total cost, including the cycle inventory, safety stock holding cost, and the ordering cost? That is a $1,350. Okay. So after this, let me compare these two systems directly. Okay. So here I'm trying to compare that the continuous review system and the period review system. Okay. So first of all, let's compare the cost. Which one is the cheaper? According to our calculation, under the continuous review system is total cost in a year is $1,259. Okay. On the other hand, what about the period review system? It's 1,350. So definitely the continuous review system is cheaper. Okay. So question is why? Why this happen? In fact, what happened is about the safety stock. Okay. So let me compare the safety stock amount under the continuous review system and period review system. That is, under the continuous review system, where you calculate the safety stock is just a G. This is from the cycle service level multiplied by sigma L. That is just a G multiplied by sigma D and multiplied by square root of L. On the other hand, under the period review system, the way you calculate safety stock is G multiplied by sigma P plus L. Okay. So that is G multiplied by sigma D and P plus L of, that is the square root of P plus L. So you can see that difference, right, between these two. Okay. So it's kind of obvious. So here's the only difference is about the continuous review, whether you apply the continuous review system or period review system, all others are just the same, okay? Such as same cycle service level, it'll be same, and then also same demand. And also even the lead time is the same. So what's the difference here? The review period. So definitely I can say is continuous review system would require less amount of the period review system. In other words, period review system needs the more safety stock amount. Okay, so I can say this kind of relationship. I can put it that way. Okay. So definitely the safety stock under the period review system should be greater than or equal to the safety stock on the continuous review system. That's why we have more cost we have to pay for the period review system compared with the continuous review system. Okay. So question is why? Why we need more safety stock under the period review system than the continuous review system? I mean, imagine that in the continuous review system, okay? So basically you under the continuous review system, you keep watching your inventory, okay? So in fact, what I can say is in the continuous review system, the only reason why you need this safety stock is because the lead time, okay? In fact, under the continuous review system, if lead time is 0, so that means you can place order and receive the ordered product right away, then you don't need a safety stock at all. Why? Even though demand is uncertain. Why? Because under the continuous review system, you keep watching your inventory. You never lose your sight on the inventory, okay? So once you find out your inventory is 0, then all you have to just place order, okay? On the other hand, the reason why we need a still safety stock under this situation, continuous review system, only because the lead time, okay? If its lead time is 0, then I can receive that ordered product right away. Then all I have to just keep watching my inventory, and once its inventory level is 0, then all I have to just place order. Then I can receive that product right away. So I don't have to worry about this stock out, okay? I don't have to hold that 0 inventory as time goes on at all, okay, under the continuous review system. But on the other hand, because of lead time, even though I place order, I have to wait for the lead time. during the lead time, still demand happening. Okay, so that's why during that time, still I have to handle this demand uncertainty only during the lead time. So that's why when I calculate this safety stock, I only consider that the demand uncertainty only during the lead time under the continuous review system. Why? Because still, again, main point here is under the continuous review system, you have to keep watching your inventory continuously. But on the other hand, what about period review system? You don't know what happened, okay, about the inventory, okay, between your visit, okay, visiting your warehouse, okay. So that's why that much the uncertainty demand is have a huge impact, okay. So that's why that under the period review system, that much you have to worry about. That is your warehouse is out of stock, okay? So that much you have to have enough amount of safety stock to cover not only during the demand uncertainty during the lead time. In fact, you have to concern about the demand uncertainty during the whole time, okay, including the review period, okay. So in fact, what happened here is, I would say that is that this greater than equal to equation, okay. But what happened to the when is equal? When the p is 0 is going to be exactly equal. The safety stock amount on the continuous review system and safety stock amount on the period review system will be exactly same when p is 0. What is a p? Review period. What does it mean that p is 0? Yeah, p is a review period. It's a time between when you place order and the next time. So if you just set review period 0, that means what? You just continuously review the inventory. So period review system becomes the continuous review system. So basically, okay, unless you switch into the continuous review system, you always have to have a more safety stock under the period review system compared with the continuous review system. So definitely here I can say that is one of the advantage of a continuous review system is what? You don't need much that the safety stock, okay? So one of the advantage of a continuous review system is require the less safety stock. Then much you can save the cost. On the other hand, what about period review system? How come? What is the advantage of period review system compared with the continuous review system? Yeah, definitely is I think it's a more realistic situation. That is, you using more the period review system more frequently than the continuous review system. I mean, imagine that you try to use a continuous review system when you try to watch over your inventory. At least you have to hire someone, keep watching your inventory, or you have to install some special machine or equipment to measure your inventory automatically without the human being, okay, as time goes on. So that much is it. So it's not convenient to watch and place order under the continuous review system. But on the other hand, the period DB system is easy, right? All you have to just time to time, you visit your warehouse, okay, and then you just check out your inventory and place order. So I can say that one of the strong advantage of period DB system is it's easy to manage inventory, especially in order and the place order and watch out your inventory. Let me just finish this writing. Okay. So in fact, according to what we learned from the example, okay, in the example, specific example, that example tells me that is the continuous review system cheaper than the period review system. But do you think it's true in the realistic case? In fact, the only reason why we have cheaper the continuous DB system than the period DB system is because we don't consider any cost what? To watch and place order continuously under the continuous DB system, okay? As I said, in order to install in order to apply the continuous DB system in your inventory management system, you have to hire someone, okay? Keep watching out your inventory as time goes on, or at least you have to install some special equipment, measure the inventory as time goes on continuously, okay? But it's gonna be very expensive, okay? So that's why normally that the periodic based system is cheaper than the continuously based system. In other words, continuously based system could be very expensive because it's going to be you require the high cost to watch over the inventory continuously. So that's why we commonly see that the periodic based system rather than the continuously based system in real cases. Okay. So only reason why in the example that is we have a less cost for the continuously based system than the periodic based system because we consider only the three costs, that is inventory holding cost and the ordering cost. If we have to add any other cost like a cost to watch, cost to hire someone to watch over the inventory as time goes on, then probably outcome is quite different. Okay. On the other hand, in these days, actually, we have so much advanced technology to measure the inventory. So like a robotics, okay? So that's why the continuous delivery system becomes the less cost as time goes on, okay, in these days, okay? So a lot of companies that become to apply the continuous delivery system over the period delivery system in these days. But still, I mean, still, I believe that period review system is more common than the continuous review system. Okay. So let me get back to the slide, PowerPoint slide here. Okay. So as I said, I classified any inventory control system into two types. The first one is a continuous review system and period review system. The difference between the continuous review system and period review system is about how you watch over your inventory as time goes on. Under the continuous review system, you keep watching your inventory. And on the other hand, the period review system, you time to time, you just visit your warehouse and then just place order. The reason why we classify the inventory control system in terms of how to watch over the inventory is because depends on whether we use a continuous review system or a period review system. The way we decided how much to order and when to order could be very different. Okay. So here's saying that is on the continuous review system. Inventory is keep watching over that continuously. And then order, the fixed amount of order is places whenever the inventory level reach the real point. Okay. That's the continuous review system. But on the other hand, period review system, you just check out your inventory time to time, especially during the certain time period, the review period, the fixed review period. And then order is placed up to what? The target inventory level to increase from the current inventory level up to that specify the target inventory level. That's about the period review system. And then here, as I mentioned, under the continuous review system, uncertainty of demand during the due time is very important. Why? Because, as I said, if we don't have a lead time, we don't need a safety stock at all under the continuous review system. Okay. So under the continuous review system, what you have to worry about only the demand uncertainty during the lead time. Okay. But on the other hand, under the periodic review system is a very different story, okay? Because under the periodic review system, you don't keep watching out your inventory continuously. So that's why you have to worry about the demand uncertainty during the whole time, including not only the lead time and also review period, okay? So in these days, you easily understand that it is so much difficult to determine the proper amount of safety stock. Why? Because the product life cycle is getting shorter and shorter, and also because of the internet, it's so easy to search the product. So that much the company are forced to increase the product availability, and also the different kind of product is quite a lot. Okay, so that much, and also customer want their customized product. That much we need to have enough amount of safety stock then, but still is a very dangerous to have too much safety stock at all. Okay, so that's why here we have some problem. Okay, so what shall we do? I mean, we have some idea here is okay about the what. Here is talking about some of the impact of affecting the fee rate and the cycle service level. That is, I already talked about cycle service level and fee rate. That the indicator of product availability. That is, if the safety stock is increased, then also it will increase the fee rate and also cycle service level. It's obvious. Okay. But on the other hand, if you increase the lot size, the order quantity, you will see that the fee rate also increase. But on the other hand, cycle service level is not increased. Okay. So how come that is? Let me get my notes here. That is, according to what we learned about the cycle service level, the way you calculate the cycle service level is just the probability average the demand during the lead time. Less than or equal to real point. Okay. And then, of course, the real point is just the average demand plus and the safety stock. Okay. So, and what about the fee rate? Fee rate is 1 minus expected short per cycle. Okay, and expected short per cycle is just the integral of the x is real point and from the infinite of x minus real point fx dx. Okay. So first of all, if we increase the safety stock, then suddenly we will increase both cycle service level and fee rate. How come? That is because safety stock is the portion of a real point. So if safety stock increase, real point increase, so that much, the higher probability of the lead time, demand during the lead time is greater than, less than real point. So that much, the cycle service level will increase. What about fee rate? If we increase the safety stock, where's the safety stock here? Yeah, real point here. Okay, so if we increase the safety stock, then much real point is increased, then much expected short per cycle is decreasing. Then what happened? After all, fee rate will increase. Okay, so definitely I can say that is to increase the fee rate and the cycle service level, you have to increase safety stock. On the other hand, there is something that you have to pay attention to. That is this one. Q. What is this? This is the lot size, order quantity. Okay. So then, but under the continuous cycle service level, we don't have it. So in fact, if you increase lot size, order a lot, then what happened? You will see that this fee rate is also increased. Okay. Why? Because if it's increased, then its entire thing is a decreasing. So it's a minus, so it's increasing. So here's the problem, that is. But on the other hand, under the cycle service level, even though you increase the lot size, it will not increase the cycle service level. So here's the problem, that is, if you order a lot, that means your cycle service level, or your, fill rate is one of the indicator of product availability. So if you simply order a lot, then can you say that that is increase your product availability? This is not about the entire volume to order in a year. This is about the when you place order, that only the one time. So can you say if you order a lot once, you can increase the product availability? No, actually it's not, okay? In fact, many company can, okay, showing that their product availability is good by simply increase the order quantity, okay? But in fact, so fill rate is not the good indicator of a product availability, because by simply increase the lot size, you can easily increase the fill rate. So in fact, when you say the product availability, you have to consider not only the order quantity, you have to consider many other things, such as demand uncertainty, and also actually how much you maintain an inventory in the system, okay? Just only one shot big order doesn't solve any problem, okay? And then increase your product availability, okay? It doesn't make sense, okay? So that's why all I can say is the cycle service level probably is better, the indicator of product availability than the fill rate. Why? Because that we can easily increase the fill rate, not only because of we have a good product availability, only because we increase the lot size, okay? So if I have a choices to evaluate some inventory control system, then I would like to choose the cycle service level, not instead of fill rate, because I believe cycle service level is better indicator of product availability than the fill rate. Okay. So let me get back to the PowerPoint slide again. So this is kind of conclusion. So here's that. I'm get into the original question at the first places I tried to answer. That is, how can we maintain a good product availability at the same time reduce the safety stock? Okay. So here's that. Is as a desired product availability increases that much, you need a lot of safety stock. And also, if your demand uncertainty is so much high, then you require a lot of safety stock. So how can I maintain a product availability, but at the same time reduce the safety stock? And certainly there is some trade-off between the safety stock and also product availability. But I already gave you the hint, that is showing this formula, that is, remember, that is, I explained about this. That is, a safety stock is just a G multiplied by sigma D and square root of L. So basically, without touching this one, that is coming from the product availability, and what we can do to maintain good product availability, but at the same time to reduce the safety stock, all we can do is just changing this one, the demand uncertainty and also the lead time. On the other hand, as I mentioned, that is, this demand uncertainty, both demand uncertainty and the lead time is not under your control. It's under the control of the customer in case of demand, and is under control of supplier in case of a lead time. So that's why here that PowerPoint, that is probably only choices you can have to maintain a good product availability, but at the same time to reduce the safety stock is you have to either reduce the supplies lead time or reduce the uncertainty in the demand. But unfortunately, you are not able to do this alone. Okay, so what shall we do? As I said, you have to cooperate with your customer and the supplier to reduce the lead time and also the demand uncertainty. So by having a shorter the lead time and also constant the demand, stable demand, by cooperating with your customer and the supplier, that way probably we can maintain a good product availability but at the same time we can reduce the safety stock. Okay. So I think I spent a lot of time today, so I think it's a good time to stop. Okay, so let me continue with this, the safety stock. There's more thing to talk about, okay, about the safety stock, okay, to manage this under the supply chain system. So let me continue with this. That is in the next time. Okay, so that's it for today. See you next time. Bye.